Hello everyone and welcome in this part type of reaction involved and the reactant used and its products. So basically biodiesel is widely used in the industrial sector and can be obtained in variety ways or reactions including thermal cracking, direct vegetable oil blending, transesterification and esterification reactions. Moreover, in this project we have selected the esterification reaction. Furthermore, the esterification reaction is an exothermic reaction, meaning that the heat going to be produced according to the Killow reaction, where the reactant and product shown in the Killow equation with presence of catalyst. So in general, what's the effect of adding catalyst into a specific reaction? Well, the catalyst plays an important role in this reaction, particularly in reducing the energy required to start the reaction, as we call it as the activation energy. So welcome in this part, selection of catalyst. There are several factors supposed to be considered while selecting a specific type of catalyst, since we can find many types of catalyst in industry. So depending on some factors which are selectivity, stability, activity, and regenerability of a catalyst. To be specific, the importance of each factor while selecting a catalyst, same as previous sequence. In particular, the selectivity known as the efficiency of catalyst towards producing the desired product, where the reaction with the same reactant but different catalysts presented may lead into different products. Moreover, the stability known as the activity and selectivity of a specific type of catalyst remain unchanged during the given reaction over time under the same condition of temperature, pressure, and composition feed. Furthermore, the activity known as when a catalyst controls the extent of a chemical reaction involved and describes the effectiveness of a catalyst towards the rate of a chemical reaction and conversion of the reactant into products, where the regenerability refers to the ability of catalyst to be reactivated to more or less its general condition. Also, another idea we need to consider as an important factor while selecting the catalyst for specific reaction, and based on scientific theories, the porous structure enables the solid to have a higher surface area. Moreover, the size and number of pores determine the internal surface area, which pore size also determines the accessibility of reactant to the active sites and the ability of diffusion of product back to the bulk fluid. In particular, we have done a conversion between three catalysts in order to compare the surface area, which we want to select the higher surface area, which was proven that zinc aluminate has the higher surface area. So basically, a large surface area can improve the chance of a successful reaction particles collision, meaning that the reactant particles will have more space in order to collide to start producing the product.
Hello, I'm Surya Tamilvanan and I'll be presenting the preparation of the catalyst that we use in the production of our biodiesel. The catalyst that we use is zinc aluminate. The production of the catalyst is basically by using a D-glucose template assisted method. The polymetric Mesoporous zinc aluminate catalyst was hydrothermally synthesized in the presence of polyethylene glycol. Metal sources with aluminium over zinc plus aluminium molar ratio of 0.5, 0.75 and 1.0, 20 grams of PEG and 5 mole of urea were dissolved in deionized water under constant stirring to achieve a pH of 5.5. and this is solution A. In a separate beaker, a small amount of D-glucose was dissolved in deionized water using ultrasonification, and this is solution B. To obtain a transparent solution, solution B was slowly added to solution A while being continuously magnetically stirred. The final solution was transferred into a Teflon-lined stainless steel autoclave, sealed and kept at 200 degrees Celsius in an electrical oven under autogenous pressure for 24 hours. After the reaction was finished, the grey solid powder was washed several times with mixture of ethanol and double distilled water before being dried overnight at 60 degrees Celsius. Finally, the dried solid product was calcined for 4 hours at 600 degrees Celsius in a nitrogen floor to remove any residual water. So basically, this is the preparation for our catalyst. Thank you for listening.
Assalamualaikum, I'm Halimatun. So I'll present the 3 suitable characterization techniques to investigate the physical, chemical and morphological property of the proposed catalyst. For this project, the proposed catalyst that we chose is sulfonated Mesoporous zinc aluminate. And so for the physical property, the technique that we chose is thermogravimetric analysis. And this technique is to determine the thermostability, contain moisture, volatile material, and detect if there is presence of the decomposition of inorganic and organic material in the catalyst. And the sample carrying heat up to 1000 degrees Celsius in the flow of air or an inert gas such as nitrogen gas during the analysis. So the advantage of this step is as to establish the optimal working condition for the catalyst, such as thermostability, oxidative stability, and the aspect lifespan of the product itself. So next, for the chemical property, the characterization technique that we chose is X-ray diffraction, XRD. So XRD is used to study the crystallinity of the post-calcined zinc aluminate samples. And for this technique, Halimatun instrument XRD 6000 with a scanning rate 2 degree per minute with a scanning range is 20 to 80 degree is used. And the advantage of this SRD is it is a rapid and powerful technique to identify unknown minerals and materials, and it requires the preparation of the minimal samples, and the interpretation of the resulting data is straightforward. And lastly, for the morphological property, the characterization technique that we use is scanning electron microscopy (SEM). SEM is able to detect the surface of any materials including the industrial metal, geological sample and biological specimens such as spores, insects and cells. And the advantage of SEM compared to TEM, this technique's response significantly quicker, it less restricted, and may sometimes be conducted with little or no sample preparation. And scanning electron microscopy allows us to analyze the surface activity of the catalyst, which can help us to maximize the biodiesel production. That's all for me.
Hello, I'm Srinivasan from Chemical Engineering Department. Today I'm gonna talk about the advantages of catalytic reactor. The first advantage of this catalytic reactor is future utilized solid catalyst, and it reduces the reactor size and plug flow characteristics, and it's produce uniform composition product at lower capital and cost. Furthermore, it's a good multi-phase mixing ability and have a controllable mixing intensity and residential time. It's so easy to screen lock the residential time and low length to diameter rates. Thank you.
Hi, I'm Faiz bin Zulkifli, and I will be presenting the current trend for biodiesel and also the challenges for biodiesel production in Malaysia. So the first is current trend for biodiesel. From the graph, we can see in 2010 to 2011, there is a decrease, a huge decrease from 86,000 tons to 55,000 tons, and also in along the year up to 2019, there is huge increases. This is due to the increase in demand in the global market for the biodiesel. Okay, so next is the challenges for biodiesel production in Malaysia. So the first point is the main material to produce biodiesel is palm oil itself, and this is for biodiesel. it will need a huge amount of palm oil, and also palm oil is very expensive since it has a highly demand in global market, and that is the first obstacle for the production of biodiesel. Second is the local companies do not show any interest in biodiesel. This is because some of the biodiesel production is not suitable for the company to use for their machines and also other stuff, and that really lowered the interest for them to invest in this biodiesel, as it also expensive. And lastly is the palm tree disease that can infect other trees around it. This will affect the production of the raw material for the palm oil, and palm oil is the raw material for the biodiesel. So for the both is highly demand in the market, and if this disease uh, does not widely affect the palm tree, it will be no obstacle for the production. And also, since this disease does not have a remedy to cure it, and so the palm tree will have less of the lifespan, and also this will decrease the production of the palm oil. So that's all from me.